Okay, in this video, we're going to be dealing with rational expressions. And a reminder that a rational expression, the root word is ratio there. So a rational expression is a quotient. It's a quotient of two polynomial expressions. Now, it says here to recall, but I want to go through and I want to make sure that we understand why this is true, because we're going to come up on this in some of our problems. X plus y over y plus x. Reminder that addition is commutative, which means you can flip-flop these around, and x plus y and y plus x is the same thing. So therefore, anything divided by itself is equal to 1. That's why that's true. Now I want to go through, now why is the second one true? X minus y over y minus x. And you can test that out. Is 2 minus 3 divided by 3 minus 2 equal to negative 1? That's going to be negative 1 over 1, which, yeah, that does equal negative 1. Is that always true? Yes, it is. Now let's talk about why that is always true. If you take x minus y on top, and on bottom, what I want you to do is think about the factoring we just went over. I want to factor a negative 1 out of this term, and I want you to see what happens. If you take a negative 1 out of that term on bottom, the y turns into a negative y, the negative x turns into a positive x. And again, this is commutative. We can flip-flop these around as long as you leave the negative with the y and leave the positive with the x. So that is negative 1 times, write the x first and write the y second. So you could actually write the bottom as negative 1 times x minus y. Now here's a trick. Anytime you have a subtraction problem, if you factor a negative 1 out, it flip-flops your two terms. So if you have, let's just show you, if you have like 3 minus x and you factor a negative 1 out of it, it turns it into x minus 3. So now that we have done that, look at your top and bottom. Those are gone, and that leaves you with nothing on top but a 1 and nothing on bottom but a negative 1, which is divisible and gives you negative 1. So now, simplifying expressions, we're going to use that exact same logic that I just showed you to simplify these. We're going to factor and cancel. That's how we simplify. The same way with fractions, let's remind you 6/10. What you were actually doing when you simplified fractions back in elementary school is you were factoring. You were dividing 6 into 2 times 3, and you were dividing 10 into 2 times 5, and you were canceling the 2's, and you got 3/5. However, you didn't have to show all that work, but that's what we're doing in this lesson. The top, 64k to the third minus 1. We're going to factor this. That's going to be a difference of cubes. Let's come over to the side and write our formula. And let's identify our a and b. In this one, my a would be 8k. My b would be 1. So let's go ahead and factor the top, and we're going to have 8k minus 1 times 8k squared, which would be 64k squared, plus 8k times 1 plus 1 to the second power, over. Now on bottom, look and see how we're going to factor this. The only way that we can factor the bottom is with slip and slide method. So let's go through it. Different color. Move the 4 to the end. Gives you k squared minus 13k plus 12. Factor as normal. That's going to be k and k. A negative 12 and a negative 1 adds, multiplies. The number that you slip, now let's divide by. And you have now, that will be a k minus 3. And move the k back up front, and that will be a 4k minus 1. Okay, so number 1. I already noticed on top it has two terms. It's not difference of squares because we have k to the third. Nothing squared gives you a k to the third. However, it is a difference of cubes because I have 4 to the third, k to the third, and 1 to the third. So let's write our formula for difference of cubes. And let's identify what is our a value and what is our b value. I know 4 times 4 times 4 is 64, and then k times k times k. So my a value be 4k to the third, minus my b would be 1 to the third. So therefore, this is going to factor. The top will factor into 4k minus 1 times 16k squared plus 4k plus 1. The bottom. Again, we're factoring and canceling. The bottom, how do I factor this? Okay, since the 4 is out front, there's no GCFs, we're going to have to use bottoms up or slip and slide method. So that's going to be, let's move the 4 to the end. That's k squared minus 13k plus 12. Two sets of parentheses, factor as normal, k and k. Adds, multiplies, be a negative 12 and a negative 1. Since you slipped the 4, now let's divide by 4. Since the first one is divisible by 4, I have a k minus 3. The second one is not divisible or reducible. Move the 4 back up front, and you have 4k minus 1. Now, again, here's the rule. You can you can cross out or cancel out an entire binomial, but you can't do part of it. You can't cancel out 4k unless you cancel out the whole thing. You can't cancel out the 3 unless you cancel the whole thing. So since you have a 4k minus 1 on top and bottom, those can cancel, and you are left with 16k squared plus 4k plus 1 over k minus 3. Now notice I don't have to put the parentheses anymore because I have only a single trinomial on top, a single trinomial on bottom, and neither factors. Okay, so you are finished. Now again, do not try to start canceling out k's with k's or anything like that. You can't cancel out k unless you cancel out the whole thing. Number 2, on top I have a common factor that can be pulled out of 12n. You're left with n minus 4. On bottom, let's factor it. 18 is a factor of both 288 and 18, and you have the lowest power of n to be n squared. Let's pull that out. 18 into 288 will go 16 times. Count your n's. You need 2. They're on the outside. Minus 18 times 1 gives you 18, and I need 2 more n's, so 16 minus n squared. Now, we're going to have to use our trick. I can already see it coming. On bottom, this is still factorable. That is still difference of squares. So on top, I still have 12n times n minus 4. On bottom, I have 18n squared times difference of squares factors into conjugates, plus, minus. 4 times 4 is 16. N times n is n to the second. You see that on top you have an n minus 4. On bottom you have a 4 minus n. So what you can do to change those around is this bottom, to flip-flop those, I told you the trick was factor a negative out of it. That negative that you factor out, you can come all the way out front, put it out here, then you can switch those to an n minus 4. And if you don't understand, go back to the first and watch why can I just flip-flop those around. Now let's see what cancels. This whole binomial with this whole binomial. Now what about over here? Can I cancel out just the 12 and 18 and the n and n? And you might be saying, well, you said a while ago I can't unless I'm going to cancel the whole thing out. Now, the rule is you can't cancel a binomial or a trinomial unless you cancel every term. This is a monomial. That's fine. You can cancel pieces of monomials. However, if you have groups like a 4 with an n, 4 plus n, you can't do that. So let's go inside here. We'll use a different color. 12 and 18 can cancel. The way we're going to cancel is by actually reducing it. Divide by 6 and divide by 6. Now let's use your rule of exponents. You have 1 n on top, 2 n's on bottom. Remember, you subtract them. 1 on top, 2 on bottom, subtract them, you're left with 1 on bottom. So here's your fraction. On top of your fraction, all that's left is a 2. On the bottom of your fraction, you're left with a negative, a 3, an n, and this. So negative 3n. And that 4 plus n, I don't like it like that. I would much rather have that as n plus 4. And that is what you're left with. Number 3. Now what we're doing is we're multiplying and dividing. Okay? And the way you're multiplying and divide is actually the same as what you were doing before. And here's why. 2/3 times 6/10. Cross-canceling. It's the exact same thing. 6 over 3, that's the same as reducing fractions. So the same way that you reduce a fraction, you can cross-cancel. So that's all we're doing here. So we're going to factor everything, and then we're just going to cross-cancel. So on top, x squared minus 10x minus 24 factors into x and x. It's a quadratic trinomial. Adds, multiplies would be a negative 12 and a positive 2. On bottom, you have a common factor of an x squared, and you're left with an x plus 2, times, here you have a common factor of a 5 and an x. Pull it out, you're left with an x and a minus 4. Here, you have x squared minus 16x plus 48, which is a trinomial. X and x, adds, multiplies, would be a negative 12 and a negative 4. And now all you do is go through and you cancel. X minus 12, the whole binomial with a whole binomial. X plus 2s, that's like reducing that one. X minus 4s, that's like reducing that one. And again, what about if it doesn't have a plus or minus? Then you can cancel the pieces. Here you had 2 x's. Here you have 1x's. Mark them out and subtract them. That's going to leave you with 1 on bottom. So all this cancels, leaves you with a 5 on top and an x on bottom, which is a great time to talk about what is the whole purpose of simplification. If I say take this expression and tell me what if x is, I don't know, what if x is 5? Plug it in for every x, divide this, plug it in for every x here, divide those two, multiply your two answers. What do you get? 1. You might say, how'd you do that so fast? Well, this is the same thing. Would you rather plug it in up here or would you rather plug it in here? 5 divided by 5, that's 1. Much easier to plug it in after you simplify. The next one. Again, we're going to go through and factor every one of these. We're going to have to use slip and slide here, so I'm going to come over to the side and do that. That'd be p squared plus 29p minus 30. Factor. That'd be p and p. Positive 30, negative 1. We slip the 5. So now let's divide by it. And I now have the top would be p plus 6 when you divide. Slide the 5 back to the front, and that'd be 5p minus 1. Over. Same thing for the bottom. We've got to use slip and slide. So I'm going to do it to the side. That would be p squared minus 20. Let me rewrite that. P squared minus 26p, slip the 5 is a positive 25, 2 sets of parentheses. That'd be p and p, a negative 25, negative 1. You slip the 5, so now let's divide by it. And you get on bottom a p minus 5. And slide the bottom back up front would be a 5p minus 1 times. Common factor would be a 3 and a p. Pull it out. You're left with a p minus 5. That's done. Common factor, well, you got on bottom, you have difference of squares. And again, I don't like the 36 being out front. I'd rather it be p squared minus 36. So factor out a negative 1. And that would turn this into a p squared minus 36. Let me write that up here. P squared minus 36. So then it would factor into conjugates, p plus 6 and p minus 6, which looks like all of our other ones now because they all have the p's first. Now let's go through and start canceling. You have 5p minus 1s. You have a p plus 6 here and here. P minus 5 here and here. Is there anything else left? That looks to be everything. So you're left with, on your fraction, a 3p on top, a p minus 6 on bottom, and then you have this negative. Where do you put it? You got to be careful. You can either put it out front. That's legal. You can put it up top. That's legal. But if you put it down low, make sure you put that in parentheses because both of those terms would have to be negative. I'd probably just put it out front and leave it there. Number 5. Now we're dividing. For division, remember we flip and multiply. So it's the same thing as what we've been doing. So we're going to factor like normal. And I'm going to go ahead and do that for you. And there's what you get. Now that one's a little bit tricky because you actually had 3 different bottoms up factorings there. Also here I see the 1 minus 4s squared. In order to get that, like the other stuff, I like to factor that negative out to flip-flop those around and then use your difference of squares. So here's what we get. Now all we have to do to divide 2 fractions is simply take the second one, flip it, and multiply. Now, if you would like to get into a habit of actually, as you're factoring this, you can go ahead and flip and multiply as you're writing it down. Either way would be fine. And there you see the flip version. And once you flip and change it to multiply, you do the same thing. You just go through and start canceling. 2s minus 1s. There's an s minus 1 on top and bottom. There's a 2s plus 1 on top and bottom. And then that's everything. So you're left on the top of your fraction, an s plus 4. You're left on the bottom, a 2s plus 1, and you have a minus sign or a negative on bottom, which can be written out front. But again, if you want to write it on top, make sure you put it in parentheses. If you want to write it on bottom, make sure you put the bottom in parentheses like it is here. Because again, in order to get rid of that, you would actually have to distribute on bottom. So to be safe, write it out front. But just know that if you have a negative in front of a fraction, if you move it to top or bottom, you do have to FOIL it out or distribute it out. Number 6. Let's go through step number 1. If you want to, you can go ahead and mark this out and change it to times. 12k squared might save you a little bit of steps. Flip the second one. 4k to the third plus 16k, and change it to multiplication, and then you can just get rid of that. So now that's our new problem. Go through, and I'm going to factor it for you. Here you have difference of squares, and once you factor difference of squares, I think you're actually going to have another difference of squares. Here you have bottoms up or slip and slide factoring. Here you're going to factor out a k and a 6. Here you're going to factor out a 4 and a k, and here's what you're going to be left with. And there you go. Now, again, look what I did here. This was actually factored into k squared plus 4 and k squared minus 4, and the k squared minus 4 factored again. And that's really the only thing that was different about these. Let's look for all of our common factors. You have a k squared plus 4 on top and bottom. Let's see. I actually have these signs wrong. Let's erase these two signs right here. That was supposed to be a plus here and a minus here. I factored that wrong. So now, and this is a great way when you're going through these problems, you can kind of get hints on what things are going to factor because they're going to set these problems up to where stuff are canceling. So 2k plus 3s will cancel. The k minus 2s end up canceling. And I'm left with, well, here, these k's. Now look, there's no plus or minuses. So these can factor like or cancel like monomials. What I mean by that, you can go ahead and cancel the k's because there's no plus or minuses. You can cancel the 6 with a 4, leaves you with a 3 and a 2 when you reduce it. So now, fraction bar, you're left with a 3 on top, and you're left with a k plus 2 on top. You're left with a 2 on bottom, and that is all. Okay, next up, we're going to add and subtract fractions. If you don't remember, to add and subtract fractions like 1/3 plus 2/5, the bottoms have to be the same. So you have to multiply top and bottom by something in order to make these bottoms the same, or you can't add or subtract them. So pretty much find a common denominator. So let's zoom in, get common denominators, combine, and simplify. So we've got to somehow make the bottoms the same. I don't have any binomials or trinomials. I have just a 4w and a 5w. I can take this bottom and I can multiply it by a 5 as long as I do it to top, and I now have 20. I have a 5 and a 4 and a w. Over here I have a 5 and a w. Well, probably need a 4 over there too. So if I multiply this by 4 and this by 4, notice that both bottoms are now the same. So the top is now 15, the bottom is 20w, minus the top is 8 and the bottom is 20w, so now it's legal to subtract. 15 minus 8 is now 7, and the bottom is 20w, and you are finished. Now, one thing to point out that when you are adding, subtracting, make sure that you remember you might be able to reduce at the end, the same way with regular fractions. If you don't have a bottom, put it over 1. If you have a binomial or a trinomial or whatever, many terms, put them in parentheses, because here's what you've got to do. Let me rewrite this so it looks better. 2x minus 1 over x plus 4, and keep those things in parentheses, minus 3 over, and I've got a 1 there. I need this same bottom. And remember that those x and 4s, they're together. So I need over here an x plus 4. How do I get an x plus 4 over here? Well, I take the bottom and I multiply it by x plus 4, and I take the top and I multiply it by x plus 4. But I've got a 1 over here, but I don't have a 1 over here. Yeah, actually you do. If you want to multiply top and bottom by 1, that's fine, but it really doesn't do anything. That 1 is really unnecessary now. So now the bottoms are the same. Now here's the number one mistake that people make on these subtraction problems. This 3 that we're about to distribute to get rid of has a negative in front of it. That minus, think of it as being, it's on the top of that fraction with that 3. Possibly, you can write it up there. So what I've got to do, my common denominator is now x plus 4. And you can leave it in parentheses if you want to, but my denominator is that. My first set of parentheses are really now unnecessary, 2x minus 1. To get rid of these parentheses, though, I've got to distribute. I'm going to take this negative 3 and turn that into negative 3x, negative 12. Now I can add my two fractions, or actually in this case subtract, by combining like terms. On top, you have 2x minus 3x, which is negative 1x. You have negative 1, negative 12, which is negative 13. On bottom, you have x plus 4, which you don't have to write in parentheses anymore unless you just want to. Now, question, can this x cancel with this x? No. Why? Because this x is paired with a 4. The top x is paired with a negative 13. So make sure that you don't cancel part unless you can cancel all. So therefore, there's your final answer. We got a few more addition subtractions. Now, before you can find a common denominator, you will have to factor. So what we've got here, I've got an r plus 5 on top. I have a difference of squares on bottom. So that's going to be an r plus 5 and an r minus 5. Plus 6 over r minus 5. Now let's do this the hard way to begin with. Look at your denominators. I need those two denominators to be the same. This one has an r minus 5 and an r plus 5. This one has only an r minus 5. So to get the bottoms the same, I just need an r plus 5. Now they're identical. But in order to get that on bottom, you must also do it on top. So now you have your common denominator, which is r plus 5 times r minus 5. And on top, to get rid of this, well, first off, those parentheses are no longer necessary. To get rid of these parentheses, I'm going to distribute my plus 6 to both of them. That'll be a plus 6r and a plus 30 now. So on top, I now have 7r plus 35. And on bottom, I have r plus 5, and I have r minus 5. Now, I told you a while ago, make sure if that top is now factorable, which it is, make sure that you factor it, because look what actually happens on top. Pull out the 7, you have r plus 5. On bottom, you have an r plus 5 as well. So those r plus 5s would actually cancel, and your final answer is going to be 7 over r minus 5. Final answer. So always check and see if it's reducible. Now let's go back to the first step. Let me erase all this extra. And let's talk about something you might have actually done before in elementary school. If you're adding two fractions like 3/6 plus 1/2, instead of finding a common denominator by multiplying top and bottom here by 3, why not reduce the other one? See if it'll clean up, because then you're dealing with cleaner numbers. Yeah, the same thing here. Look, r plus 5s could have actually reduced to begin with, and you've already got a common denominator of r minus 5. Now you can just add 1 plus 6, and you would have got that exact same answer. Number 10. 5a plus 6 will not factor, so I know that's not going to reduce. The bottom, a squared minus 4, is difference of squares, so let's factor into conjugates, plus minus the a's and the 2's. Minus, you have a 1 over a plus 2. And again, I always like to leave these things in parentheses just to show you they're grouped. So on bottom, the first bottom, I have an a plus 2 and an a minus 2. On the second bottom, I only have an a plus 2, so I need an a minus 2. To get it, I'm going to multiply top and bottom by a minus 2. Now you have a common denominator. So the top is now 5a plus 6. And I'm going to distribute negative 1, not just the 1, to get rid of parentheses. So that's be negative 1 times a and a negative 1 times a negative 2. The bottom stays the same, a plus 2, a minus 2. Combine your like terms on top. 5a minus 1a is 4a. 6 and 2 is 8 over a plus 2 times a minus 2. Always to check to see if the top is factorable. It is. Pull out a 4, you're left with an a and a 2. And this actually then is reducible. On bottom, you have an a plus 2 and an a minus 2. Therefore, the a plus 2's can cancel. Final answer, 4 over a minus 2 is your sum. Let's do some more. Number 11. Factor first. You have q plus 1 over q minus 4, and those are not factorable, so you can go ahead and put them in parentheses if you'd like. Minus the q minus 1 is not factorable. This bottom is. Two sets of parentheses. A q and a q adds, multiplies, negative 3, negative 4. So now we just have to make the bottoms the same now that we have them factored. Here you have a q minus 3 and a q minus 4. Over here you need a q minus 3. So multiply top and bottom by q minus 3. And you have the same bottoms now. So the bottom is q minus 4 times q minus 3. Now look what you have on top. You have this, which must be multiplied together, minus this. So let's go ahead and let's multiply these two together. That gives me, and if you need to do it to the side, that's fine. Q times q, q times negative 3, 1 times q will be plus 1q, and then 1 times negative 3 is negative 3. So that turns into q squared Combine like terms, that'll be negative 2q and then minus 3. Minus this stuff. So does everybody see there's actually a negative 1 there that's being distributed? So that's going to turn that into a negative q and a plus 1 to get rid of it. My top is now q squared. I can combine this q with this q, be minus 3q. And a negative 3 and a positive 1 gives me a negative 2 over q minus 4 times q minus 3. Now that might be our final answer, or I'm going to try to factor that top just to see, does it reduce? So let's see, what on top, q and q, what adds to give me negative 3, multiplies to give me a negative 2, and it seems like something should, but it actually doesn't. That doesn't factor, so therefore it won't reduce, and that is your final answer. Number 12. Okay, number 12. Again, if you'll look, group these together. They're not factorable, but if you'll group them together, it just helps see that what those denominators should be. So you have a 3 over x plus 6. And I'm going to write this out so I have a little bit more room. Then I have a minus, then 2 over x minus 1. To make the bottoms the same, watch how easy this is. Here you have an x plus 6. You don't have one over here. So tack on an x plus 6. Top and bottom. Here you have an x minus 1. Over here you don't have one, so tack on top and bottom an x minus 1. And that's your common denominator. That's it. And again, from there, the biggest mistake that people make is they don't group this 2 and the negative together. Make sure that when you distribute, that you distribute not a 2 but a negative 2. So here you have 3x minus 3. Here you have negative 2x minus 12 over that common denominator, x plus 6 times x minus 1. Combine your like terms. 3x minus 2x gives you 1x. Negative 3, negative 12 gives you a negative 15. And luckily, that's not factorable, so we don't even have to worry about reduction, factoring, and all that. And that's it. We're done. And again, reminder, don't try to cancel x with the x's. You've got to cancel the whole thing if you're going to cancel part of it. Complex fractions now. What a complex fraction is a fraction within a fraction. So here you've actually got 5 different fraction bars. So to do these complex fractions, what you're going to do is combine the numerator and denominator into a single fraction. And then we're just going to treat this like a division bar. So this is no different from what we've been doing. So what I like to do is I've got the A part and the B part. I'm going to do the top and the bottom separately. So A part, let's zoom in. So A part, I'm going to do 1 over 10 minus 9 over 40 r to the second. I've got to somehow subtract those. So that's just another common denominator problem. I have a 40 and a 10, so I'm going to multiply top and bottom by 4. So there we go. We can just do it like that if you'd like to. And now I need an r squared on the bottom over here, so multiply by r squared. If you do it to the top or bottom, make sure you do it to the top. So now I have 4r squared minus 9 over 40r squared. Now I noticed something that's factorable, so I'm going to go ahead and factor it. 2 sets of parentheses. This is difference of squares, so it factors into conjugates, a 2r times itself, and a 3 times itself. So 2r plus 3 and 2r minus 3. The bottom is a monomial, so you can't factor it. Now the bottom of the whole thing now. There's the top. The bottom of the whole thing is, let's see, 1 over 3 minus 1 over 2r. We need the same denominator. So 3 and 2, that's like regular fractions. I need, let's say I can change them both into a 6. So I'm going to multiply top and bottom here by a 2. I'm going to multiply top and bottom here by a 3. So now I have 6. There's only a problem. There's an r on this one, not on the other one. So multiply top and bottom by r. So now here I have 2r. Here I have a negative 3 times 1, which is a negative 3, over 6r. So now what do? Here was the top. This was A part. This was B part. This large fraction bar in the middle means divided by. You can picture it like a giant fraction. The top divided by the bottom. Now, how do we divide fractions? We just a while ago did it. You take the second fraction, you flip it, and you multiply. So we're going to do the top. Let me do it in a different color. We're going to do the top, which is 2r plus 3 times 2r minus 3 over 40r squared. To divide it, you're going to flip and multiply. So the bottom becomes 6r over 2r minus 3. Notice I put the parentheses around 2r minus 3 so that I see they are paired. The 6 and the 40 can cross cancel because there's no pluses there. Divide them both by 2 and you get a 3 and a 20. I have 1r here, 2r's here. There's no addition or subtraction tied to it. So we mark them out and subtract them, and I'm left with a single r on bottom. Your final answer, 2r plus 3 over 20r. Now later on we'll talk about that could be distributed. Since it's a monomial on bottom, you could distribute and divide both of those by 20r, but not today. Let's do another one. Let's see, that was number 13. Number 14 now. Again, part A and part B. On top we have, for A part, we have y to the third, I put y to the second, y to the third over 2 plus y to the second over 6. I can very easily get a 6 on bottom here just by multiplying by 3. So the top's done. I have 3y to the third plus y squared. Those won't combine, so we leave them over 6. There's A part. B part, I'm going to write that as 1 over 1. So 1 over 1 plus 1 over 3y. I need a 3y over here, so I multiply top and bottom by 3, multiply top and bottom by y. Now the denominators are the same. On top, I have a 3y plus 1. On bottom, I have a 3y. Now, I noticed something else on top. I should have factored this. I should have went one step further because the top is factorable. I have y's in common. Take the smallest power and factor it out. That's going to be a 2. You're left with a 3 and a y here. You're left with a plus 1 here over 6. So now to divide these two fractions, and again, this giant fraction bar does mean to divide. I'm going to take the top and leave it the same. Y squared times 3y plus 1 over 6. And I'm going to multiply by the reciprocal of the bottom. Flip and multiply. And I'm putting 3y plus 1 in parentheses so I can group them together. Those cancel. I'm left with, let's say, 3 and 6 I can cancel with a 1 and a 2. So I'm left on top with 2 y's here and a y over here, and that's it. And then I've got a 2 on bottom. So on the bottom you have the 2. Y squared times y, don't leave it like that. That would be a y to the third if you use your rules of exponents. Number 15. This is the last one. The top, A part and B part. A part, we need a common denominator. We have 4m over 5n plus n squared over 10m to the second. Your common denominator is 10. I need a 10 here, so multiply top and bottom by 2. That gives you a 10. I need an m squared over here, so let's multiply top and bottom by m squared. Well, you already have 1 on top, so let's put 2 more of them up there. Now you have 3. I got an n here. I need an n on bottom over here, so multiply top and bottom by n. You already have 2, so now you have 3. Now you can add them, and that's a pretty ugly denominator. Let's see, that's going to be 10 m squared n. 10 m squared n. And I'd put them in alphabetical order just for simplicity's sake. You have 8 m to the third plus n to the third, which I regret seeing because that is actually sum of cubes. So when we go to factor that, we're going to use our sum of cubes formula that all of a sudden magically appears every time I say it. So there's your sum of cube formula. This would be 2m to the third power. This would be n to the third power. So your a in your formula is 2m. Your b in your formula would be n. So when you factor the top, it factors into 2m plus n times 4m to the second minus the product, which is 2mn, and then plus n to the second over 10 m squared n. So now we're done with the A part. So now let's do the bottom. There's the top. The bottom hopefully will be a little bit easier. So B part, you have 1 over n squared plus 1 over 2mn. So over here you have just an n squared. Well, I need a 2, so we can solve that really easy. So multiply by 2. We need an m, so let's multiply top and bottom by m. So now they're nearly the same, except for here I have 2 n's. Here I only have 1, so let's multiply top and bottom by another n. So now I have 2, and on top I have 1. So that cleans up to, I've got my common denominator, which is 2mn squared. On top, I have a 2 times 1 times m, which is 2m, plus 1 times n, which is n, which was much easier than the first one. So now to divide the two, I'm going to flip the second one, and I'm going to multiply, so the first one stays the same. So I have 2 for the first one, 2m plus n times 4m squared minus 2m n plus n squared, all over 10m squared n. Flip the second one, 2m n squared, and multiply 2m plus n. That's a binomial, so let's put it in parentheses. Let's now cross cancel our 2m plus n's. Since these do not have plus signs, I can cancel my 2 and 10, leaves me with a 5 and a 1. My m's, I have 2 on bottom and I have 1 on top, so I can use my rules of exponents there, mark them out, and I'm left with a single m on bottom. Same thing with my n's, I've got 1 and I've got 2, mark them out, subtract, I'm left with 1 on top, and that gives me my final answer. I'm left with an n, and I'm left with all this stuff in parentheses that didn't cancel, 4m squared minus 2mn plus n squared. And then on bottom, I'm left with a 5, and I'm left with an m. So there is my final answer. Again, the stuff in parentheses would not cancel because you would have to cancel the whole set and not just part of it.